Today, as an introduction, my name's Jonathan Keller. I'm the CEO of and one of the co-founders of LifeFloor. And like I said, I'm working from my home office here, as most of you are probably joining from your home office. We are in stay-at-home protocol, but we're obviously anticipating at some point we'll be able to gradually relax that and start seeing people go out. And so now is the time to invest in learning and understanding things. So we are excited to talk about our topic today, which is about cleanability and impermeability in the new NSF 50 safety servicing standard. The overall standard, we're not going to go into a ton of detail about that because we did that in a previous webinar. But today we wanted to dive into the different testing protocols, and we're going to do a series of them over the next few weeks to talk about all 6 different testing criteria or testing protocols that were established in the new standard for safety servicing in NSF 50. And we decided to start with cleanability and impermeability, given the state of affairs with a global pandemic going on. We wanted to make sure people, there are standardized tests we've created to show, okay, how do we make safety servicing cleanable? Because when things start to open back up, they're going to want to make sure that they can be sanitized. So just as a brief overview, what is NSF and why is it important? So NSF is a crucial organization, both now and over the long run, because they deal with global human health. So in a situation like we're in right now with the global pandemic, it's really important that products have to meet standards, that they get tested, they get audited, and get certified by a third-party organization that's really trying to make sure that people are educated and are avoiding risk in safety situations. So the NSF has standards across all different types of industries and areas. So things like drinking water and drinking water equipment, things like food service and that kind of equipment. They also have a standard 50, which is related to recreational water. And standard 50 just came out with a new version in January, which has a safety servicing standard, which if safety servicing wants to be certified to this standard, they have to meet 6 criteria. And we are going to be talking about cleanability and impermeability today, as those are pretty relevant right now. And what are we doing here at LifeFloor? So like we've had a desire since we founded the company 9 years ago to make sure that families are protected and safe when they are enjoying recreational water environments. And so one of the things we want to do is create a product that can, make healthier and cleaner environments for guests or people who are enjoying areas where they're barefoot and wet. So the standard was a result of the standard that specifically for safety servicing was a result of a task group that made recommendations, and then a joint committee, which I'm not a part of, but was able to make recommendations to, voted on, and then it went through the full standards process where regulators voted on it, and then the ANSI committee voted on it. But the original task group that kind of came up with these standards was looking at, all right, how do we make splash pads, how do we improve servicing from concrete? So if we're going to add a safety servicing, how do we improve it from concrete? So the first criteria, we're looking at impact attenuation and slip resistance, which we'll talk about in a later webinar. But the other questions were, how do we make sure it doesn't become, if we add safety servicing, we don't create a public health problem by microbial growth happening? And so that's where concrete's the baseline, and we want to improve from concrete. So we have in the task group, we had architects, we had consultants, we had engineers, we had operators, we had regulators, and we had manufacturers all working together to try to figure out how do we create a better standard. And so we took all those constituents who all have different, somewhat aligned interests, but somewhat different interests, and said, how do we create a standard? And so we created 6 different testing protocols to try and, make sure that when we're going to put safety servicing in, that it's going to be safer, it's going to be durable, and it's going to not cause, it's going to be at least as good as concrete in terms of public health. So the two testing protocols we're going to talk about today are two testing protocols that didn't exist before this standard. As a task group, we looked at all different types of testing protocols that could have come about, but we didn't have one that made sense for cleanability in a aquatic environment for a safety service, and we didn't have one for impermeability in aquatic environments. So the NSF task group, as well as basically the laboratories at NSF, had to try a bunch of different options for tests and figure out what would actually make sense. Because the goal here in a safety surface is to prevent injuries, but you also don't want to have microbes growing. And so what we looked at was, all right, let's put a safety service to testing and also put concrete to testing. Let's create a situation similar to what could happen in a splash pad environment, which, as many of you know, the most common type of public health type of concern in a splash pad environment is a code brown or some kind of fecal incident. And so what we try to do is recreate a fecal incident on a safety surface or on concrete by creating a slurry, which was like a brown paste that was basically there were two different ones created, one for Enterococcus and one for Pseudomonas, that were then spread onto the surface. And if there is a joint, it was put into the joint, and then it was allowed to incubate for 24 hours. And so then the goal is, all right, how much did it grow in that 24 hours? And then we applied the Model Aquatic Health Code cleaning process, which involves putting a solution of bleach onto a surface, allowing it to sit for 10, 15 minutes, and then taking that off, and then measuring how many of the organisms are still there. So the goal here is to test, is a product able to be sanitized? Because that's obviously crucially important. If a product can't be sanitized, then it's probably going to create more problems. And it may solve some problems in terms of injuries, but if it creates more problems, that becomes a challenge. So this test was created, and we'll talk about what the criteria were for passing the standard. But this was done, and we performed it on both concrete and life floor when we were developing the standard to see how did it work and was it effective or not. The second standard then is, all right, so say a product can be cleaned, at least the surface, but what happens if it absorbs things? Because then you may not be able to measure what's getting inside of it. So then we also had a testing protocol for, like, let's make sure stuff's not getting stuck inside, because that's another area where things can grow and fester. So we created a testing protocol for impermeability, because we want to have a product that's impermeable so that you can be assured that when you're cleaning it and when you get all the stuff off the surface or out of the joints or wherever, that you've gotten everything and stuff's not stuck inside it. So what we did on this testing protocol is we created basically a cylinder with water and then a flange where we put the flooring material underneath that cylinder of water. We would measure the flooring material before and after it's basically allowed to sit under, with exposed to this cylinder of water for 24 hours at room temperature. And we'd figure, okay, what was the change in mass over that time period? Then we were doing that for concrete. We did that for life floor, and then obviously any future safety service that wants to be certified to the standard would do that as well. But again, this was a situation where a test didn't exist before this, and so we had to create a test that was like, okay, what's going to be a common situation now? In most splash pads, they're not going to have water, unless it's an underwater one where there's some sort of depth of water. A lot of splash pads are drained, but they will have constantly running water on them, at least during hours of operation. So like this was an extreme version, having water constantly soaking on it for 24 hours, which in some situations would happen, like a small play pool. But in many situations where the water is designed to run off, it wouldn't be. But in either case, we wanted to see, okay, what type of water was being absorbed. If you have, just as a reminder, if you have any questions, you can put those into the chat bar, and we will answer those at the end. But feel free to put those into the group chat as we're going through this. So what are the actual criteria? So we've talked about the tests. What are the actual criteria for passing to meet the new NSF 50 standard on safety servicing? So in cleanability, we really are looking, in most situations in the aquatic environment, we're looking for a 3-log reduction, or a 99.9% greater reduction of microorganisms. And so that's what we were able to achieve on concrete. So when you do the Model Aquatic Health Code cleaning process on concrete, with the testing that we talked about with that slurry, you are able to get a 3-log reduction of those microorganisms that grew. Likewise, you're able to do that with life floor, even life floor when you've got joints, 2 tiles butting up against each other, which was important for us, just to make sure that we're not supporting the growth of microbial microbes. On the impermeability side, the standard was, again, we're trying to use concrete as the baseline, since concrete is the most common surface used in splash pads around the world. We wanted to say, okay, it can't be any worse than concrete. So what we did on that test, when we put the concrete in under that cylinder for 24 hours and then measured it afterwards, concrete is about 97.4% impervious. So it actually, the weight change, or the percentage change, was about 2.6%. So that means, all right, if you want to pass the NSF standard, you actually have to be at 2.5% or better for your product to be accepted. Life floor is actually 99.7% impervious. So, and this is including joints and all of that kind of thing. So like our tiles just are non-absorbent, and more non-absorbent than concrete. So the question then is, what do we do with that information? So obviously there is a standard that now exists, and many of the pool codes in the United States and around Canada reference that standard, NSF 50, for certain parts or sometimes in whole. And the standard, what it does, which is really beneficial, is if in most pool codes around the United States and in Canada and many other places around the world, there are stipulations that pool decks and splash pads need to have an impervious and easily cleanable surface. But there's never been an objective test for that. And now there is. That was one of the big goals here, is like, this is what regulators wanted, was an actual test that you could have an objective criteria of, like, is a surface impervious, is it easily cleanable, and because the goal of those things is, can it be sanitized? So now there are objective tests that wouldn't necessarily require codes to be changed around the United States or around the world. It just means that they need to adapt an objective measure. So one of the big things that NSF is doing, and that the industry can now do, and we're doing, is educating people about the benefits of having a standardized test for regulators, so that we can go to all the regulators around the world and give them, hey, here's an example of a test that can work, so that you have an objective measure for these stipulations in your already existing codes about surfaces being impervious, and about tiles, or about products being cleanable. So that's something that we've been very excited about, is because there's just, before we were sort of left with no objective measure, and now there is an objective measure. And so that's something that the education as we move forward. So those of you who have, who are operators, or who have clients who are operators who already have existing splash pads, if, there have been questions on the public health side of, like, we really have issues here. Looking at an NSF 50 certified surface could be helpful to make sure you've got an easily cleanable surface and you've got an impervious surface. because there's objective testing that can be done to show that it is, versus if you don't, if there are issues right now, you can, this is something you could adapt or change to. So just want to encourage, if anybody has any questions, you can put those in the chat for the group. So just either, you can either message to everyone, or you can message to LifeFloor directly. I'm going to go back to the past webinars page. So if you, or you know somebody who's going to want a copy of this webinar presentation afterwards, make sure to go to lifefloor.com/webinar-registration, and then you just fill out a quick form, and you can get access to all the previous webinars and this webinar after we're done.